You open the browser, type in your favorite website, press enter, and, just like magic, you can help the new and improved Zuckerberg 2.0 sell your private data to the highest bidder while watching motivational reels. While the psychology behind finding joy in mindless scrolling is quite interesting, this is a tech channel, so in the next couple of minutes, we'll look at the magic part that makes wasting our lives on the internet possible. Despite the apparent simplicity of accessing a website, what you might not realize is that there is a long history of hard manual labor and fascinating tech innovations behind the seamless process of navigating the web. We all know that the internet is a massive network of interconnected computers. Locally, your device might be linked to the network via Wi-Fi, 5G, or even a satellite dish. On a global scale, however, around 99% of the world's international data is transmitted through thousands of miles of fiber-optic cables stretching across continents and oceans. These cables are about the size of a garden hose, and they are protected by layers of insulation and steel to withstand damages from fishing nets, ship anchors, and natural events like earthquakes. Laying these cables is no small feat. Picture massive ships slowly laying cables across the ocean floor, navigating underwater mountains and trenches. It's a process that takes years of planning, billions of dollars, and the kind of patience most of us lost in the age of 10-second TikTok videos. Once these cables are in place, they connect massive data centers spread across continents, which require industrial-strength ACs and liquid cooling, while consuming more electrical power than a small town. If this sounds like an exaggeration, remember that the average Google data center consumes enough electricity to power 200,000 homes annually. As you can imagine, the utility bills for these facilities can easily get overwhelming. So many data centers are built in cold places, like Iceland or Finland, to save on cooling costs. And this is just the physical side of the internet. The software protocols, algorithms, and engineering behind this infrastructure are even more fascinating. So, when you access a website, you are looking for that website server in a very complex network of millions of interconnected nodes, each uniquely identified through a combination of numbers called an IP. IPs are quite harder to remember for humans, so we use uniform resource locators instead. URLs are strings that follow a strict pattern with a scheme indicating the use protocol, an authority composed of the domain name and the port, the path to the resource, a list of parameters where additional data is sent as key-value pairs, and a fragment referring to a specific part of the document. Once you press enter, the first thing the browser does is to map the URL to an existing IP address. These mappings are managed by the domain name system. The DNS acts like a huge phone book for the internet, translating human-readable domain names into machine-readable IP addresses. This process is called DNS resolution and involves several steps. First, your browser checks its cache to see if it already knows the IP address. If not, it asks your operating system, which in turn queries a DNS resolver, usually provided by your internet service provider or a public service like Google or Cloudflare. The resolver might also have the address cached. If it doesn't, it starts a series of queries climbing up the DNS hierarchy. It all begins with the root DNS server. This is the system that actually drives the entire internet. What's interesting is that it is composed of only 13 servers distributed across the planet. The number might seem low, but each of these instances is part of a large network of over 1,500 physical servers distributed globally to ensure redundancy and resilience. The root points the resolver to the top-level domain servers associated with the domain the user is looking for. This can be .com, .org, or any of the other hundreds of possible extensions. These TLD servers then direct the resolver to the authoritative name server for the specific domain. Finally, the authoritative name server provides the IP address, and this is returned to your browser. Now that the browser has the IP address, the real work can finally begin. Remember that all these steps are done by sending information through light over thousands of miles of fiber optic cable in milliseconds, just so that someone has the best user experience possible when they swipe left you. Since the channel of communication between our browser and the server is pulsing light traveling through fiber optic cable at 200,000 kilometers per second, the exchange data has to be divided in very small chunks called packets that can easily travel in this medium. The primary responsibility of TCP/IP is to create these packets and send them to their final destination, ensuring the packets can be put back together on the other end of the communication. Packet management is a complex and fascinating topic involving segmentation, sequencing, and error handling, definitely deserving of its own video. To give you a sense of the complexity involved in managing packets, note that each packet of data is typically 1500 bytes. So if you're streaming a 1 GB movie, that's over 700,000 packets being sent to your device. For the purpose of this discussion, it is enough to know that TCP allows data to be transferred reliably to its destination. Both the sender and the receiver must agree on connection parameters before actually establishing the connection in a process known as a three-way handshake procedure. First, the client informs the server that it wants to establish a connection by sending a synchronized package. Then, the server responds with an acknowledgement package, and, finally, the client sends back another acknowledging message. Of course, each step is done via the network, so these packets have to traverse the entire distance between the client and the server for each step of the handshake. Crazy stuff. So at this point, your packets might have covered a distance similar to the entire circumference of the world, but we are still far away from receiving and displaying the page in the browser. Once the TCP connection is established in a process that feels like an eternity, but it actually takes just a few milliseconds, the client and server can finally exchange messages using the Hypertext Transfer Protocol, or even better, its secure extension. This is where the transport layer security handshake often comes into play, ensuring that your data is encrypted and secure. This handshake is performed through another round of server-client communication steps. Once the browser's request is approved, the server will usually send back a success response along with the requested resource. When the first request is made from the client, the first packet that arrives as response marks the time to first byte. This is an important metric that represents the time elapsed since the request was initiated and when the first chunk of data was received as a response. It includes the time taken for the DNS lookup, the TCP handshake to establish the connection, and the TLS handshake if the request is made over HTTPS. Once the browser receives the server's response, it begins processing the data. The HTML structure is parsed, external resources like CSS and JavaScript are fetched, and everything is assembled into the web page you see. This process, known as rendering, transforms raw data into the user interface and is a story for another day. If you enjoy this type of content, you should check some of my other videos. Until next time, thank you for watching.